Okay, so I'm going to go over the Solving Linear Equations and Absolute Value Equations worksheet for you. This is a great worksheet to review for the test because it has them all mixed in together, equations, absolute value equations. So looking at number 1, we have 2/3 W minus 1/4 equals 7W plus 5/12. First thing I noticed that there's fractions all sprinkled through the equation. So I'm going to use Fraction Buster. I'm going to find my least common denominator, which would be 12. I'm going to multiply every term by that 12. So I multiply by 12 to the 2/3, multiply by 12 to the 1/4. Make sure to multiply by 12 to the 7W, and multiply by 12 to the 5/12. So we use some cross canceling. 3 goes into 12 4 times. 4 times 2 is 8W. 4 goes into 12 3 times. 3 times 1, and it's minus -3. 12 times 7 is 84W, and the 12 divided by 12 is 1. 1 times 5 is 5. Now we have an equation with no fractions, so that's the nice thing about Fraction Buster. So I'm going to subtract my 8W, and then I'm going to subtract my 5 over here. So I get -8 equals 76W. Divide both sides by 76, and then I can reduce this by 2. 4. -8 divided by 4 is -2, and 76 divided by 4 is 19, so W is equal to -2/19. Okay, so my next problem is asking us to solve for y, and I want you to notice that this equation has 2 variables in it. So I'm not actually going to get a numerical answer for y, I'm going to get a different equation, and it's like taking a standard form equation for a line and putting it in a slope-intercept form. But we're not always going to be working in the slope-intercept standard form realm. But right now, if I want to get rid of my I want to get 8y by itself first, so I need to get rid of my 6x. So I'm going to subtract 6x from both sides. So -8y equals -6x minus 24. And if you like to write it as -24 minus 6x, that's fine. I just have a habit of putting my x first, so it looks like y equals mx plus b. And then I'm going to divide both sides by -8 to get y by itself. And y equals 6/8, negative makes it positive, 6/8 reduced to 3/4 x, and negative is plus, 24 divided by 8 is 3. So now I've taken that equation and solved it for y. Number 3, this is a different type of equation. You might first see 2 fractions, but what you're really looking at as a proportion, and so we can solve this by cross multiplication. 2 times the 5h and 6 times the h minus 9. So I get 6 times the h minus 9 is equal to 2 times 5h. And that's 6h minus 54 equals 10h. And I'm going to subtract my 6h. So -54 equals 4h. Divide by 4, and h equals, I can reduce this by 2, so 54 divided by 2 is -27, and 4 divided by 2 is 2. So h is equal to -27/2. You need to stop thinking that if you got a fraction as an answer that you did something wrong, because it's perfectly acceptable to get fractional answers in Algebra 2, which may not have been the case. You might have always worked and got pretty clean whole numbers in geometry. So here's a little bit of geometry for you. A equals 1/2 BH, which is the formula for a triangle. So we're going to get b by itself in this equation. So the first thing I do is multiply by 2 because I want to get rid of that fraction. And when I multiply by 2, I get 2a equals b times h, because 2 times 1/2 is 1. Now I need to get the b by itself, so I need to get rid of the h. So I know that h divided by h is 1, so if I divide by h divided by h is 1, and I'm left with 1b on that side. So b is equal to 2a over h. And remember that in equation sign, you can flop an equation sign and it doesn't change the value or the equivalency. Number 5, 2.3c minus 7 equals 0.4 plus 5c. So we have two options. We either deal with the decimals or we eliminate the decimals. And here we can do decimal buster by seeing that in this problem we have 2.3 and 0.4, which are both decimals in the tenths place. So if I multiply the whole equation by 10, my fraction or my decimals will go away. So I get 23c minus 70 equals 4 plus 50c. Now I have an equation without decimals in it. Same thing is true if it had two decimal places. The hundredths place, you would have to multiply by 100 to get rid of the decimal. Let's see, let's subtract the 23c. I have a tendency to keep my variable positive, so I will move the variable to the side that has the larger coefficient. When we do this, 23c minus 23c is 0. We get negative 70 equals 4 plus 27c. And we're going to subtract 4, and we get negative 74 equals 27c. Then I'm going to divide both sides by 27, and we get negative 27, oops, did that wrong. Negative 74 over 27. This is not reducible, but it's also approximately 2.74 is your C. So when you have a problem that starts with a decimal, it's okay to write your answer as a decimal. What we don't like about this as a decimal is that I had to round this answer because this is a repeating decimal. It was 740, 740, 740. So really the most accurate answer is to write it as the improper fraction. So now we're going to get into some equations that have the absolute value in them, and we went over this Monday, the 21st. We want to think about these absolute value equations and remember what the absolute value means. If we say the absolute value of negative 5, we know that equals 5. And the absolute value of positive 5 is also 5. So what we're looking at is really kind of trying to cover up what's in here and say, what can the inside be equal to? And if we look at our equation, it says we know that the absolute value of a plus 5 will equal 7. And that means that a plus 5 can equal positive 7, or a plus 5 equals negative 7. So to find what a is, we solve each equation separately. Subtract 5, so a is equal to 2, or when I subtract 5 here, a is equal to negative 12. And when I go up and look at my original equation, I say negative 12 plus 5 is negative 7. The absolute value of negative 7 is 7. Okay, so here's another equation that has all variables, and we're asked to solve for one of them. We're asked to get a by itself. So the first thing I need to do is work on getting the b on the other side. So I'm going to subtract b from both sides. I get ax equals c minus b. And I can't actually do c minus b because I don't know the numbers, so we're just going to leave that. And then I'm going to divide by a, and I get x equals c minus b over a. And that's what x would equal. This comes in handy a lot in physics. I don't know about physics nowadays, but I remember my physics teacher always made us solve the equation for the variable we were going to need and then plug in the numbers afterwards. So sometimes science teachers really like you to be able to do this. Number 8, we have variables on both sides. We have parentheses. So the first thing we need to do is use my distributive property. Negative 2 times x is negative 2x. And negative 2 times negative 8 plus the 1 equals negative 2x minus 7. So don't forget about this little guy. He's lonely out there, and don't forget to bring him down as well and include him in your next step. So I have negative 2x. We'll combine my like terms. I get negative 7 equals negative 2x minus 7. Well, these are the same exact thing. So on this side, if I were to add my 2x to get rid of it, my variable goes away. I get negative 7 equals negative 7, which is always true, so it's all real numbers, which we're not going to write all the time out in words because we much prefer symbols, which is a double-lined R. That's our symbol for all real numbers. So any number we choose to plug into that original equation would work. Okay, so next, number 9 says solve for p. I have two p's in the equation, so I need to work on getting the p's by itself. And I have this weird fraction on the second, or the right side. But if I look at it, it's just p minus 6 divided by 2, and I can pretty simply multiply both sides by 2 to eliminate the fraction. So I get 6p equals p minus 6. Subtract my p, and 5p equals negative 6. Divide by 5, 4p equal to negative 6/5. So it's a problem that kind of looks a little daunting, but really if you sit down and think about what it's actually asking you to do, it's not really that complicated. So let's remember number 10, we're doing absolute value again. When do we write our two equations? We have to wait until our absolute value is by itself. So I'm going to subtract my 4 first, and then I'll deal with what the absolute value could equal. Absolute value of y minus 6 is equal to 12. That means what we have inside here, if this was not there, whatever it is has to equal either 12. So we'll write one equation for that. Y minus 6 could equal 12, or y minus 6 can equal negative 12. Both answers will give me an absolute value of 12. So we can solve that. Add 6 to both sides. We get y equals 18. Or add 6. Y equals negative 12 plus 6 is negative 6. So we have two answers, 18 and negative 6. Most absolute value equations are going to have two answers. There's only one case when it doesn't, and that's when it equals 0. Every once in a while, we're going to look at that next. You have extraneous solutions that when you plug them in, they don't work. Number 11, once again, we have to get the absolute value by itself before we can deal with writing our two equations. So the first thing I'm going to do is subtract my 1, then I'll divide by negative 5. So minus 1 from both sides. Negative 10 equals negative 5. Absolute value of k plus 2. Now some of you might see, oh, there's a negative on that side. An absolute value can never be negative, but I have to get the absolute value by itself before I can make that determination. And when I divide by the negative 5 to get the absolute value by itself, it turns positive. So I get 2 equals the absolute value of k plus 2. So the k plus 2, what's inside the absolute value, can equal 2, or it can equal negative 2. And subtract 2, so k can equal 0. Remember that 0 is a valid answer. And k is equal to negative 4. Number 12. Same idea. Let's get our absolute value by itself. Let's subtract the 7. And I get the absolute value of d plus 12 equals negative 4. And now here we're in that situation. The absolute value is by itself on the one side of the equal sign, and there's a negative on the other. And the absolute value can never equal a negative, so there isn't any number you could plug in that's going to make it break those rules and come out negative. So we say there is no solution Okay, save yourself some work, and when you get your absolute value by itself, evaluate the signs on the other side. Is it positive? Okay, then I need to write my two equations. Is it 0? Okay, I know I only need 1 because there is no negative 0, and if what it's the absolute value is equal to is negative, it's no solution. There's no need to write two equations, and there's no need to do more work. These problems we give you as like quick, easy problems. All right, and we are now to the last three problems. The absolute value of 3y is equal to 12. So we have two equations. 3y, can equal 12, or 3y could be negative 12. And when you divide by 3, we get y equals 4, or divide by 3, y equals negative 4. Very rarely does your problem turn out to 4 and negative 4. The other way you could write this are plus or minus 4. It doesn't come out like that when you're adding or subtracting to the number inside the absolute value. So number 14 looks at an equation that has variables on both sides, but one side has the absolute value. So we can say that whatever's inside has to equal positive 2x plus 1, or the opposite, negative parentheses 2x plus 1. So let's see what that looks like when I write my two equations. X minus 6 equals 2x plus 1. Or, I'm going to encroach on the space over here, x minus 6 is equal to negative, outside parentheses, 2x plus 1. The whole expression has to change signs. So I get x minus 6 equals 2x plus 1, or x minus 6 equals negative 2x minus 1. Now I can solve my equations, minus my x, and I get negative 6 equals x plus 1 minus 1, x equals negative 7. And don't be too quick to say, oh, the answer can't be negative, but we will have to check because it is possible to get extraneous solutions when we have a variable equal to an absolute value. So then I can add 2x here. So 3x minus 6 equals negative 1. Add 6 and 3x equals 5. Divide by 3. And x is 5/3. So we have two answers, negative 7 and 5/3. And because we have a variable on the second side of the equation, we have to check to see if any of them is what's called extraneous. Extraneous solution is a solution that you get when you solve, but when you plug it back in, it does not work out. And it happens a lot of times when we have functions that have a range restriction. So here we have the absolute value, and if I plug in negative 7 here, and negative 7 for the second x, I end up with negative 14 plus 1 on this side, which is negative 13. And the absolute value on this side is going to be a positive 13, so we know this ends up being an extraneous solution. So my only solution is probably that 5/3, but I should check it. And I want to look at what's called sign analysis as well without actually having to do the work. You can do that by saying, I'm plugging in a positive number here. Positive 5/3 times 2 is going to be positive, plus 1 will stay positive, and the absolute value is going to come out positive, so yes, that should work. When I look in sign analysis with the negative 7, I should immediately see that's negative, and when I put that negative in and I add 1, it's going to stay negative, so then it cannot work. Okay, I had to magically make some space for our next example. The last one. The absolute value of 4y minus 7 is equal to 0. This is the case where we have only one answer, even though or we only write one equation even though we have absolute value, because it's equal to 0 and there's no such thing as negative 0. So 4y minus 7 is equal to 0. Add my 7. 4y is equal to 7. Divide by 4. And y is 7/4. 3/4. These are the problems where we should be cheering because they're a little bit less work. So you need to recognize when the absolute value equals 0, you have one equation. You need to recognize when the absolute value is equal to a negative, there's no solution, so that you can save yourself some headache and some work and some time.